So we are looking at a Bernoulli differential equation. Your question, you can forward your question. Welcome on board. Welcome. I welcome everybody. Welcome to this channel. Okay. So then the next thing to do, this is what we have now. We are going to conform this to standard form. Okay, and this will be equal to what? This one is having y to the power 1, so I'll have 1 minus 2. So I'm dividing this one by y to the power 2, this one by y to the power 2, this one also by the same y to the power 2. So I'm going to have s squared in this place. So, and this will give me this one. So that's what we have in this case. Then we can now, another step is to make substitution for whatever that attaches to p of x. V, call it V, equal to what? Equal to this. And differentiate this B implicitly respect to x. So we have the V dx as what? As this is minus 1, as minus 1 y to the power minus 2. Okay, dy dx. One thing about implicit differentiation is that you do it as if you are differentiating with respect to y. Then you now put the y dx by this side. So that's all we have. So call this one equation 1, call this one equation 2, call this one 3. So if you check 3 and 1, they're almost the same thing. Look at this one, is here, it's also here. So, but this minus is not here. So I'm going to inject this minus 1 to equation 1. So multiply equation 1 by minus. So minus. So then you can now substitute, plug in your equation 2, equation 3 into this new equation. Okay, plug in 2, 3 into this new equation. So we're going to have this one is the v dx. Okay, and minus 1 over x. This one is what? Is v. Okay, equal to what? Equal to minus x squared. So that's that. So this is now linear in v. This is linear in v, and then we solve it in a linear differential way minus x. It's linear in v. So whatever that attaches to v is called the p of x, and then you have to consider the sign also. So get the integral factor. The integral factor is what? Is e to power integral minus will be outside 1 over x dx, and that would be what? E to power ln natural logarithm of x. Don't forget the minus that we have here. So the minus will come on top here. That will be equal to what? X to power minus 1. So that's on that case. And don't forget, I've explained when you have e to power of ln of a function, that is going to give you that function. It's going to be equal to what? F of x. So that's what we have. So we've gotten the integral factor. Then we need, don't forget the f of x. These are f of x. So we need it in getting the general solution. 1 over integral factor, which is 1 over x. Open your brackets, integral. Your integral factor is this times the, what do you call it? F of x, which is minus what? Minus x squared, then dx, then plus what? Plus c. Okay? Plus c. So that will be equal to this one, 1 over x. Inverse of that will give us this. And this one, 1 here, 1 here. So we have integral of minus what? Minus x dx plus what? Plus c. Then do the integral of this one. So this is having power 1, so plus 1. So that's equal to what? Minus x squared over 2 plus what? Plus c. And that's that on that question. Let's start on that question. Making question 2. Bernoulli differential equation. Remove this one from here. That will give you y to power minus 2, the y dx. That's the first step. So minus this one also. This is y to power 1 minus 2. So we are having y power y squared. So that's what? That will be minus 1. That's minus 1 equal to what? E 2x. So that's the first step. And the next step is to make substitution for this one. Call it v equal to this. And differentiate this one implicitly and that will be dv dx is equal to what? Minus 1 y to the power minus t to y dx. Okay, so the next thing to do now is to call this one equation 1, equation 2, equation 3. So I want this equation 1 to have minus also. Why? Because what we have here is also the same thing as this one. Just this minus is a difference. So multiply equation 1 by minus. So I'm going to have this one. I can plug in equation 2, equation 3. But if you look at this one times 1. If you check this one, and equation 3 is the v dx. Is the v dx. Then plus. This one will be what? This one will be v. This is v. This is v, and then we have what? We have minus e2x. So this is linear in v. This is a linear what in v. So whereby p of x is equal to what? Is equal to 1. My p of x is equal to 1. So in that case now, I can get the integral factor. I can get the integral factor, and that will be equal to what? E to power integral of 1 dx. That's what? That's this. So that's the integral factor. The attachment to v will be p of x. So the attachment of this one is 1. The coefficient of v, this place, is 1. So, and don't forget the q of x is equal to what? Minus e to power 2x. So that's what we have in that place. So then we've gotten the integral factor. We can get the general solution x equal to what? Equal to 1 over integral factor, which we have as this. Open your brackets, integral factor times what? E to power 2x. That's your q of x dx, and then plus c. So we can combine these two together, and this one will be what? E to power minus x. Open your brackets, that will be e, this one and this one, e3x. These are your indices, the same base, dx plus what? C. So finally, don't forget the integral here, okay? That's the integral. So, so if you missed the video, like I made a live video on linear differential equation, please quickly check it, okay? So check the video to quickly to be updated on how to solve linear differential equation. So this will be equal to what? If you integrate this one, e function to give you back, but you divide by the derivative of the power. So that's 1 over 3 plus what? Plus c. So that's that on this. I want to say welcome. If you are just coming in, welcome to the channel. If you are just a returning viewer, I will say thank you. So you can send the links of this live broadcast to your friends and friends and friends and friends. Make it a multiplier effect. So let's see another question. So what we do is that whatever that is here, we expect, this is power 1, this is the x. We expect solution, we expect to have something of x also. So that will be plus 1 over t this. That's what we expect to have. Then move this one to the other side, and that's what t x cubed. So that's what we have now. Okay. So whatever that is here, the variable that is here must be here. So, and then you must have that variable also must also be here, but it must have a power. So that power must not be 0 or 1. Okay. So then divide through by this one, the x, the t, and then plus this one will give us 1 over t. That's x to the power minus 2 equal to what? Equal to t. Then make substitution for this place. Call it d equal to what? X to the power minus 2. Then differentiate this one implicitly. Respect to the function you have there. Respect to t. Previously, all of them has been x, but this one is t. So respect to t. That will be the v dt equal to what? Minus 2 x to the power minus 2 minus 1 minus 3, and that will be what? What you have there, the x what? The x dt. That's the implicitly. Okay, you do it that function as if you are doing differentiating with respect to its function. Actually, this one is a function of itself, and at the same time, it's a function of t. So you do it with respect to x, and then the x to t by the side. Okay, if it's y that is here, it will be the y to t. So this is what we have now. So can we call this one equation 1? Can we call this one equation 2? Call this one equation 3. Okay. So what we are going to do here, you can see this one is there. But there's a difference there of minus 2. So multiply equation 1 by minus 2. That's 2 over t. X to power minus 2. And then equal to minus 2 t. This place also times minus 2. So we have done that. Times minus 2 is there. Times minus 2 times minus 2. So then this we now do another thing again. We're now going to plug in 2 and 3, equation 2 and 3 into this new equation. And this is what? This is the v dt. This is the v dt minus 2 over t. This one is what? This one is that's what? That's c. So this equation now is now linear in v. For it to be linear in v, whatever you have here and here must be the same thing. So this is linear in v. So we now have it's going to be p of t, because our function is a function of t. Equal to what? Equal to minus 2 over t. Okay, then you can now write your integral factor as a function of t, and that will be what? E to power what? Integral minus 2 can be outside 1 over t. The what? The t. If the function is x, that will be the x, and this will give us integral of what? Minus 2 ln natural logarithm of t. Okay, that will give us t to power minus 2 as the integral factor. I've explained this one many times. Okay, you can check calculus 1, calculus 2 for more information of this. And what I said previous question is that when you have e, okay, when you have e function to power of natural logarithm of a function, okay, it's going to give you that function. It's going to be equal to that function. So we've said that many times. And this minus 2 will come on top here. Okay, and that will be t to power minus 2. For you to solve Bernoulli differential equation, you must know linear differential equation, because what we are doing is that we are changing the form, okay, to linear differential equation. That's purely what we are doing. Okay, please, if you're new, subscribe now so that you can forward your question, and then forward your question, a new question, a fresh question. I guarantee you will make a live section for your question. Okay, you can do it now. Okay, and this aspect is very important. This aspect that I've been taking over the years, and any student I take, they always have A, B. I'm not boasting. They have A and B. The testimonies are there. Okay, so I will just say at this moment, they're watching me. Please, this is not a joke. This is not entertainment. Take your journal, take your pen, and begin to write. Begin to follow along with me. Take your pen, take your journal. The more you do that, the more you understand faster. You understand faster. Okay, this is not this go beyond just watching. You need to take your journal and begin to follow along. Okay, step after the step to get the general solution as a function of t, and that will be 1 over integral factor. I've skipped something there. I've cleaned the integral the other side of the equation, so that's it. I've cleaned that side. I think let me check the question and see, bring it out. Okay, I think okay, I'll generate that. So 1 over integral factor, that's t minus 2. Open your brackets, integral factor, t minus 2, my q of x. That's my q of x. Yeah, that's minus because initially it was this, and this one was removed from that place. Next thing we did is to multiply by what? We multiply 2 by minus 2. So that's what we have there. And don't forget the t, then plus what? Plus c. Okay? Nothing come by chance. Nothing come by chance. Okay? Nothing come by luck. Okay? Luck is what? Preparation meet with opportunity. Okay? The more you practice, the more you prepare, the more you practice, the more lucky you become. The more you study, the more lucky you become. That is a fact. Okay? So this is what we have now. Then we now have this. Okay? We can combine this one and this one together. This is power 1. So that will be t to power minus 1. This minus 2 can come outside the integral. The minus 2 can come outside the integral. Then we have this. Okay? So we now have 1 over this. Okay? Open your brackets. Then we have minus 2. If you integrate this one, this minus 1, this minus 1, which is same thing as what? Same thing as 1 over t. The t. Because if you want to apply this, the normal integral rule, because it will make sense. But there are tables, there are rules. Okay, you follow the rules, you find mathematics are simple. There are 2 major ways. Okay, then the other ways. Okay, but 2 important ways to be mathematics guru is to follow the rules, the laws. What are the laws for that aspect? You follow the laws, and then you now begin to solve as many questions as possible. The more questions you solve, the smarter you become. You think fast. Okay? The more questions you solve, okay, you think faster. The smarter you become. You follow the rules, you follow the laws, then you begin to solve as many questions as possible. And that is what math sci consult is doing. There is no aspect we are not solving as many questions as possible. In linear differential equation, we solve like up to 6, 5. And those questions also, part of them is. So I want to say at this moment, one of the ways to advance this channel quickly now and begin to follow your fresh question live section for those questions on this particular so when we get to the next section also, I'll also give you the opportunity to do that also. Plus C. Plus C. This will give us natural log this. I'll give you. The first time I saw this questions, the inspiration are just coming in. Sincerely, first time I saw it, I could not solve it. But the moment I begin to solve as many questions as possible, my understanding open. I begin to think faster. Okay? So please don't forget to smash that subscribe button. Forward your fresh question. I will make a live section for those your question. Thank you. So that's that on this particular question. This question is very, very interesting. And the funny thing is just the variable we have there, the variable t. But that's not a problem. That's not a problem. Okay. Let's see another question. Let's see another question. Yep. Yep. It's a question. There's no solution there. Then this is 2r theta, 2r theta over theta squared. So this will be equal to this one solution, the theta, equal to that will be r squared over theta squared plus 2r theta over theta squared. So this one we cancel, it will mean 1 here. So we're going to have the theta. So whatever you have here, I'm expecting to have r also. So it's going to be move this one to the other side, and that will be minus what? So it's theta squared minus 2 over theta. This r you have here must power 1. This is power 1. This must be power 1. Okay, and then equal to what? Equal to 1 over theta square r square. But the other one is going to be r, but this will be what? Multiple. Must not be 0 and it must not be 1. If it's 1, it becomes linear. If it's 0, it becomes linear. So you can now see now this conform to standard form of Bernoulli differential equation, which is what? It is what's differential? Q of x, y, equal to what? Q of x to power n. Okay? So the next thing to do now is that you look at your function with respect to theta. Respect to what? Let me permit you to sit down. So it's respect to theta. This is respect to theta. So it's going to be p of theta equal to what? Minus 2 over theta. They get the integral factor. Get the integral factor as a function of theta. Okay, and that will be equal to what? E to power what? Integral. These two can come outside, minus 2 1 over theta, the theta. And that will be equal to what? E to power natural logarithm. If you integrate this one, that will be ln theta. Okay, minus 2. Okay, and that will be what? Theta to power minus 2. And that's what? That's 1 over theta squared. So that's what we have in that place. So we've gotten the integral factor. Welcome. I'll keep welcome you. Welcome to this channel. You are welcome. This is one of the best place to be. Okay, this is one of the best place to be for your questions on these aspects. Then the next thing to do now is to get the general solution. To get the general solution. The general solution the general solution is going to be that will be y as a function of theta equal to 1 over integral factor. Integral factor is 1 over theta squared. Open your brackets. 1 over this, that's all. And then times q of x. What's our q of x? I don't know why we obtain it. Let me see if I can remember. We got I think we are left with 1 over theta square r square, and then we remove this one from here. Okay, so I think is 1 over theta square. That's the other side. You can check the one. You can check your right up. And I've told you the best thing to do. This go beyond looking. Okay, looking. You have to take your journal, take your pen, okay, take your paper, and begin to work alone so that you can get assimilation. Then in the class, you're just looking at your lecturer. You will not understand until you begin to write. That is one of the principles. Begin to write. Okay. Even if the thing is complex, at least you get 10% of what the person has said. Begin to write. Okay. Very important. I'm not joking. Very important. Okay. You take this aspect very serious. If it's a course you are offering now, you will know there's a fire on money for people in year 2. Okay. Take your journal, take your pen and paper. This is not entertainment. I'm not dancing here. Take paper, take a pen, begin to work along. Okay, that is the best way to comprehend. Okay, so this one cancel. Then one, so move to the other side. Move to the other side. I don't want to make a mistake. So that will be the r, the theta equal to, move this one to the other side, minus 2 over theta r. Okay, then equal to this one, 1 over theta square r square. Okay, then we remove this one from here. We remove this one from here, and that got r minus 2. I'm going to repeat this solution again. Pardon me for that. I'm going to repeat the solution again. I'm going to repeat the solution again. Okay. I'm going to repeat the solution again. This is the question we have. I try to use Bernoulli differential equation. So this is what we have. And I've told you there's no solution here. There's no solution. Okay. So this implies that this one, do the algebra. That's the first thing to do. Do the algebra. That'll be this one over this one plus 2r theta over what? Over theta square. That's the first thing to do. Do the algebra. Then this is r. So we need something also to follow. We need another r to follow. So this will be the r, the theta. This one and this one will cancel. So minus 2 over theta r, yeah, equal to 1 over theta square r square. Must be this same variable, same variable, same variable. But this one will be higher. 3 power 2 power 3. Okay. Then remove this r square from here. And that will be what? Minus r to power minus 2. The r, the theta, minus 2 over theta. 2 over theta. So this will be r. This will be r1 minus 2. Equal to what? 1 over what? Theta square. Then this will be what? R minus 2. The r, the theta, minus 2 over theta. This will be r minus 1. Equal to what? 1 over what? Okay. Then make substitution for this one. Call it v. That's what. Then differentiate this one implicitly. That will be the v respect to what you have here.